Worksheet, transformations of quadratic functions. Okay, so we'll do the odds and we'll do some of the evens together as well. Reminder that we're not doing the bottom four on the first page in the front. So we'll do the odds here and we'll do most of the back together. Before we do, I want to go over the little reference box that's on the side of your notes that we gave you in class. I'm going to zoom in. You want to take a picture of this or get the notes online that are attached right by the video link. You want to have access to this. You can use these notes on your quiz that's coming up in a few days. Okay, so the big things that we want to remind you of on this is you're looking for the number and you're looking to see if a number is inside parentheses or outside parentheses. If the number in your quadratic equation is inside parentheses, then it's changing the graph horizontally. Okay, it could change it by moving it left or right, or it could be a horizontal stretch. A horizontal stretch would be you have your parabola and you pull on it, it makes it wider. Or a horizontal compression. You squish in the parabola horizontally, it makes it narrower. Okay, but it's all in terms of horizontal. If the number is not in parentheses, it's outside parentheses, then similar things are happening, but it's all vertical stuff. It could move up or down vertically if you have a number on the end. It could also have a vertical stretch. If I had a parabola and I pull on it vertically, it's going to make it skinny, just like a horizontal compression makes it skinny, okay? But we don't call it horizontal if it's outside parentheses. It would be a vertical stretch. Likewise, a vertical compression, if I have my parabola and I squish it down and compress it vertically, it makes the parabola wider. Okay, so all these different things that are happening. All right, so keep that in mind. We're going to be going back to this as we do this paper. So let's take a look at number one. It says write an equation of the function g of x, so ours is going to be g of x, and describe the effects on the graph of the parent function f of x equals x squared. So they're starting with this, the parent function that we all know, and let's go ahead and put that in the calculator. F of x equals x squared. Now you don't need a calculator to do these, but since we're still getting used to it, it's good to just check on the calculator. So this is the parent function we start with, the one we've been using for a few weeks now. But here's what they say. The change is going to be, what if we add on a number d? And they're saying the d is 6. So basically, you have your f of x, but you're adding a 6 onto the end. Now first of all, we didn't change the number in front, right? The number in front of the x didn't change. So nothing is getting narrower, nothing is getting wider. All that's happening is a translation, which means it's either moving up, down, left, or right. That's all that's happening. So this 6 is not in parentheses. It's outside of parentheses, so that tells us it's a vertical change, so it's either moving up or down. Okay? The vertical changes happen the way that we would expect them to. It's actually going to move up. So what I'm going to do, I'm going to put in my x squared, and I'm going to do plus 6. We see it go 6 up. It just translated up 6. So it's a vertical translation up 6. Okay? Now let's do number 3 together. Number 3 is a little different. I'm going to show you how you can actually put these in the calculator. I'm going to get rid of my red equation because I don't need it anymore. Let's go ahead and put in this. So g of x is equal to a f of x, meaning we're putting a number in front now. So when you put a number in front of that x squared, because f of x is just x squared, right? When you put a number in front, it is going to make it either get skinnier or wider, something like that, right? So notice that -2 is not in parentheses, so it is a vertical change outside of parentheses, another vertical change. The number is bigger, it's getting bigger, so a number that gets bigger is going to make it skinnier. So what do we call a vertical change that makes it skinnier? We call it a vertical stretch. We're stretching that thing to make it skinnier. So it is a vertical stretch. We could say by a factor of 2, but you don't even have to say that. Just say vertical stretch for now. Now, it's not the only thing that changed. Not only did we put a 2 on there, we put a negative on there. So it also is a reflection. So we'll just say, and it reflects. And there's more details about reflections that we're not going to get into right now either. Okay? This is a lot, and I'll get into later on future videos ways where you can put this in the calculator and see what's happening. But for the sake of time, I'll go ahead and move on. If we have time at the end of the video, I'll go back and do that. Okay, so we're going to go ahead and do on the back, we'll do all 3 of these because it's just matching. It's going to be, I'm already doing 2 of them. It's obvious what the last one's going to be. So we're going to match each equation with the correct graph. So if you have a calculator, the easiest thing is to just type that thing in and see what it looks like. But we don't have a calculator. So let's try doing it without the calculator and then see if we can match it, and then we'll check. So I'm looking at all 3 of these guys. I'm noticing one of them has something the others don't, and that is a negative sign. As soon as you have a negative sign, you know you're reflecting. And only one of these flips the other way. This one flips the other way. Okay, so I'm already thinking that number 10 is A. Okay, now let's check everything else and see if it works out. This one went up 3, and I have a +3 on the end there. Is that a vertical change? Yeah, when you have it outside of parentheses, it's going to make it go up or down, and a +3 would make it go up. So that checks out too. And then the negative, like we said, flipped it upside down. That's what made us already match it up. The 1/2 in front, not in parentheses, is going to make the graph get a little bit wider than the parent function. So I'm already thinking that 10 and A go together. Let's go ahead and graph 10. I'm going to get rid of my old graphs. Let's go ahead and graph it just to make sure. So I go to my graph screen, and I put in negative 1/2 x squared +3. Oops, it went ahead and I think my enter button is kind of sticky on this. It didn't let me put in the +3. So I'm going to double click on it and now put in +3. So there we have it. It did go up 3 and it is going down. It looks just like that one. Okay, so 10 is A. Okay, let's take a look at these other guys. So here we have another +3, and it's also outside of parentheses, so we should have another one of these graphs that went up 3. Okay, because we already used this one. This one's A. This one does not have a +3 on the end. This one did not go up 3, but this one did go up 3. We're done with A, so I don't need to look at that. This guy from the x-axis went up 3. He did. This guy from the x-axis didn't go up at all. He's still on the x-axis. So I'm already thinking that 11 goes with B, because B has a vertical translation of up 3. We know it's vertical because it's outside of parentheses, and when it's vertical, a plus makes it go up. And this one did go up. Let's check the rest of it. We also have a +3 in parentheses. That's a horizontal change. We learned that the horizontal changes are opposite of what you would think. That should make it go 3 to the left. This guy did go 3 to the left. He was over here, and he went 3 to the left. He went 3 to the left, and he went 3 up. The half made it get a little bit wider, which is hard to see because there's no parent function to compare it with, but it does look like it is a little bit wider. Okay, we can graph that to check it. and I put in my 1/2, and then my parentheses, and then my x plus 3, and then I square it on the outside of the parentheses. It's important to see that. So I square it, and then I put a plus 3 on the end. I don't know why. Every time I'm doing that, it's already graphing it, and I'm not done putting it, my equation in. Okay. So there it is. It looks just like choice B. It went left 3, it went up 3, there it is. Got a little bit wider. Okay? So it's obvious what the other one's going to be, but let's go ahead and take a look at it. The other one did not go up or down, okay, because there's no plus or minus a number that is outside of parentheses. So there is no vertical translation. Okay, but it did shift 3 to the left. This 3 in parentheses is a plus 3, and when it's in parentheses, the horizontal change is opposite of what you would think. It did go 3 to the left. The 1/2 made it get a little bit wider than the original parent function. Okay, so A was 10, B was 11, C was number 9. Okay, let's do number 13. Sketch the graph of each function, identify the vertex and the axis of symmetry. Okay, so we know the parent function starts right here and goes up like that. So from the parent function, I have this -4 on the end. It's outside of parentheses. I know that that is a vertical change outside of parentheses. I also know it moves accordingly to what we would think. A negative, in other words, is going to go down. So our graph is going down 4. Okay? But I'm not done. I can't put a point here yet. I have another translation right here. This is a horizontal change, which means it's left or right. It's a plus 2, and that makes it go opposite. The horizontal changes are the weird ones. It's going to go left 2. So it goes down here, but it's also already gone left 2. That is my new vertex. All right? What happens to my graph? Does it reflect? No, it doesn't reflect. So this is pretty much the graph. I'm just going to sketch it. I'm not going to get exact points. If you had a calculator, you could get exact points, but we're expecting you to do this at home without a calculator. Now, if you do this, don't do this part, it's probably okay, but I'm going to go ahead and do it because they asked for it, and it's pretty easy now that we have the graph. The vertex is -2, -4. And the axis of symmetry goes right here. That would be x equals -2. Okay, so you'll do these two guys the same way. The error analysis, the last one we'll be doing together. Cody described the transformations of the graph f of x equals 5x squared. So he started with this one, and he changed it to this one. G of x equals -5, parenthesis x minus 9, quantity squared plus 12. So one of these things that he did is wrong. Okay, let's take a look. Does it reflect across the x-axis? Now there's two types of reflections. We haven't covered that, but all we need to know for now is, does it reflect? You have a negative added on. You did not have a negative before, so yes, it does reflect. Does it have a vertical stretch by a factor of 5? Well, that would be determined by, is there a number in front? Well, there was already a 5 in front. There's still a 5 in front. It didn't actually change. It went from being in parentheses to out of parentheses, but the number didn't change. So this one is iffy. I'm thinking probably not correct. Okay? Translation 9 units to the right. There is a 9 in parentheses, and we do know in parentheses it does go left and right, and it goes opposite of the sign. So the -9 makes it go 9 to the right. That is correct. Translate 12 units up. We do have a 12 outside of parentheses, so that is a vertical change. Does plus 12 make it go up? It does make it go up. You could also graph this in the calculator, and you would see it go 9 right. You'd see it go 12 up. What you wouldn't see is it getting skinnier. It's going to be the same type of graph. So that's the one that is the error.